Hi students, welcome to Math 107 class. This is our first lecture, and as such we're going to start with some of the concepts that you have seen in your Math 096 class or intermediate algebra. Okay, so the first thing that we need to look at so you can refresh your memory is algebraic expression. So when you see this algebraic expression, it means what? A combination of numbers and variables. So example of algebraic expression would be 2x or x squared plus 1 or 2mn minus k. So every connection between variables and numbers, we call them as algebraic expression. So our first task would be simplifying them. So we do some exercises on this. Simplifying algebraic expression. Okay. So let me go ahead and look at this. And I know you know order of operations, so that's why we are going to jump into dealing with this kind of expression. X minus 4 cubed. So this is another instance of an algebraic expression. So if we want to simplify this, and let's give a value to x. Let x is equal to 6. So meaning what? Wherever there is x, you plug in the value of 6. So you would end up with 7 plus 5. And then instead of x, you plug in 6. 6 minus 4 to the third. And now you're going to use your knowledge of order of operations, so which you know is called PEMDAS, right? First, you have to deal with the stuff in the parentheses, then the exponents, and so on. So, according to PEMDAS and using the order of operation, you would end up with 7 plus 5. Then we have to simplify the one inside the parentheses. 6 minus 4 is 2, and raised to the third power. Right? Now, before I multiply this by 2, I have to raise 2 to the power of 3, because that's what the order of operation tells me. So I would end up with 7 plus 5, and 2 cubed is 8. Then you go ahead and multiply 5 by 8, you would end up 7 plus 40, so you do number 47. Your answer becomes 47. Okay? Let's do another example of this. Suppose we have 8 plus 6 x minus 3 to the second, and let's assume x to be 13, right? Again, as we just did a while ago, then we can use 8 plus 6, replace x by 13, so you end up with 13 minus 3 squared. Then go ahead and simplify the one inside the parentheses, which is 10 squared, because 13 minus 3. Then go ahead and square 10, which is 100. And now you are going to multiply 6 by 100, 600, then you end up with 608. Okay? Once we do that, there is another concept which you have seen before, which is the absolute value. One thing that you need to know about the absolute value, and I know you know, is everything that it has to always be positive, meaning what? The absolute value of negative 2 is 2, and the absolute value of 2 is also 2. Right? So anything that comes out of the absolute value always carries positive real number. So let's look at some exercises so that you can see. Suppose you have, let's say, the absolute value of 10 minus 4. Look, so what I'm doing is I have to simplify the numbers inside the absolute value. 10 minus 4 is 6. It is the absolute value of 6 is equal to 6. What if I do 4 minus 10? And then I can do what? 4 minus 10 is what? Negative 6. If the absolute value of negative 6 is 6. So whichever way we write, we end up with the same outcome. What does this mean? You know, when you do commutative, a minus b is equal to b. If we say a minus b is equal to b minus a, you would say that is wrong. Because if I say 5, if my a is 5, is my b is 3, 5 minus 3 is not the same as 3 minus 5. Therefore, we know subtraction is not commutative. But what if I plug in the absolute value of a minus b is equal to the absolute value of b minus a? Again, I can use this example. The absolute value of 5 minus 3, which is the absolute value of 2, is the same as saying the absolute value of 3 minus 5, which is 2. Okay? So this and this statement are the same, whereas this and this are not the same. So that is the idea behind the absolute value. Okay. So what we can draw from this is then we get the absolute value of A if we plug in negative A or A, we get the same outcome. For two different signs of the same value, we're going to get the same outcome. Okay. Now, once we are done with this, then we're going to look into, again, I'm heading a little bit faster because you know about this in your online 6 class. So, let me take you back in simplifying the algebraic expression again. And this time without including any value, without giving any value to it. So let's say 2x squared plus 4x plus 10 times 4x squared plus 3x. This kind of algebraic expression, and we're going to use an absolute value also in this. That's one of the reasons why I plug in. I decided to discuss about the absolute value. You can't combine anything in the parentheses because they are of different degrees. One is of the second degree and the other one of the first degree. So what we are asked to do is to distribute 6 to everything inside and 10 to everything inside, and then simplify that. So if I distribute 6 to 2x squared, I will get 12x squared. If I multiply 6 by 4x, I get 24x. I'll do the same between 10 and here. So this is 40x squared, and then 10 times 3 with 30x. Now what I'm left with is what? Combined like terms. I have 12x squared, I have 40x squared. If they are of the same degree, then I can add the coefficients. The coefficients are 12 and 40, which gives us 52x squared. And then 24x and 30x are also of the same degree. Then I can add 24 plus 30, which gives us 54x, and we're done. Okay. Again, I'm going to use another example. Let me work this out. Suppose I have 8x plus, then I'm going to go to, I have a bracket, then 5 minus x minus 3 and everything closed. Let's try to simplify this. Look, we have a bracket and we have a parenthesis. First and foremost, we have to simplify everything inside the bracket. So I'm going to rewrite without touching anything, 8x plus 2. I'm going to write 5. Mind you, if you have a negative here, that means 1 is implicitly there. So 5 minus 1 times x minus 3. So I'm going to distribute. I'm not touching 5. I'm going to distribute. Minus 1 times x is minus x. Minus 1 times minus 3 is plus 3. So what I did is I got rid of the x minus, the parenthesis that covers x minus 3. And now I only have the bracket. So I'm not going to touch 8x and 2 yet. I'm going to bring it down. Now I have 5 and 3. So let me write 5 plus 3 is what? 8 minus x. 5 plus 3 is 8 minus x. Okay. Now the order of operation tells me what? It is at this juncture that I'm going to distribute 2 to everything inside. So I have 8x plus 2 times 8 is 16, and 2 times negative x is negative 2x. Now you can see clearly you have 8x and negative 2x. If you combine them together, you're going to get 6x plus 16, and then you're done. Okay. I think we can do one more of this. So, and let me do this. 6 plus 4, and I have 7 minus x minus 2. It's almost similar to the stuff that we did. Again, leave 6 and 4 alone, including 7. As we discussed, there is 1 in there implicitly, so negative 1 times x gives us negative x, and negative 1 times negative 2 gives us positive 2. Then let's do it again. You have now 7 plus 2 is 9, and then you have minus x. Now all you need to do is what? Distribute 4 to 9 and x, so it will be 36 minus 4x. combine these two together. 6 plus 36 gives you 42. 42 minus 4x, and then you're done. Okay? All right. Okay. Now, we will be talking now exponents. And again, this is also a concept that you have seen in your intermediate algebra, so I'm hoping it will not be that difficult. In exponents, there is what we call the power rule. The power rule and the product rule. In fact, we also have, let me put it in here, the quotient rule. So if we know these three rules, then it's not that difficult to understand the concept behind it. The power rule tells me if I raise a to the power of n, okay, and in fact, let me use another a number without even a variable. Let's say if I raise 2 to the third power, and if I raise again 2 to the second power and I multiply these two, what I can do would be, since the base is the same, it is the same as raising 2 to the power of 3 plus 2. Meaning what? If you have the same base, when you multiply them, just go ahead and add the exponent. So this would be 2 to the power of 5. And this makes sense because 2 to the power of 3 is what? 2 times 2 times 2. 2 to the second is what? 2 times 2. And how many 2's do I have? 1, 2, 3, 4, 5. So 2 to the power of 5, which in essence is 32. Okay. In other words, if I have a, any number a, raised to the m, and if I have another number a raised to the n, to the nth power, if I'm going to multiply the base, all I need to do is what? Go ahead and add the exponents. It would be a to the n plus n. That's what we call the product. Now, the product, yes. Now let's go ahead and do the power rule. Suppose I raise 2 to the power of 3. Okay, so this is the product rule. Okay, suppose I raise 2 to the power of 3, and I raise that to the power of 2. What I'm doing is, I'm raising it 2 to the power of 3 times 2 to the power of 3 because I'm raising it to the second power. And you know by the product rule, it is what? Because I'm multiplying the same base, I'm adding the exponents, 3 plus 3, which is equal to 2 to the, 2 to the second, and this is 2 to the second. Apologies. 2 to the third, and then 2 to the 6. Okay, you end up with 2 to the 6. But instead of going to the product rule, the power rule is an easier concept. So if you, instead of doing the product rule, go ahead and multiply 3 by 2. 3 times 2 is 6, 2 to the power of 6. In other words, if you have b raised to the mth, b to the m, and that is raised to the nth power, go ahead and just multiply the exponents. So this would be b to the mn. Okay. All right. Now let's go ahead and do the quotient rule. suppose you have 2 raised to the 5th power and it is divided by 2 raised to the 3rd power. So let's just go in. What is 2 to the 5th power? There are how many 2's? 5 of them. 4 and 5. And then 2 to the 3rd power, there are how many of them? 3 of them. So if you cancel each one of them, the top and the bottom, you end up with what? 4 or 2 to the 2nd power. Or, because you are dividing the same base, what you can do is you can subtract the denominator from the numerator. So in other words, if it is 2 to the 5th over 2 to the 3rd, it means 2 to the 5 minus 3, which is 2 to the 2nd, which is 4, which is 2 to the 2nd, which is 4. So you see, you get the same outcome. This is what we call the quotient rule. Okay? Now, once we know that, then we can easily simplify exponents in whatever shape and form they can come. So, let's do this. You have 6x to the 4th, y to the 3rd, and you have 5x squared, y to the 7. So in this exponential expression, you have numbers and you have 2 variables. So it is probably easier. I'm doing this the long way, so that you can see what we're talking about. So I have 6 and 5. So they are the same number. So I'm going to do, so this is 6 times 5. I have x to the 4th and x to the 2nd. So I have what? X to the 4th times x to the 2nd. I'm combining like terms. Y to the 3rd and y to the 7. Okay. You know 6 times 5 is 30. Now x to the 4, x to the 2nd, the rule is what? The product rule. You have the same base, all you need to do is what? Add the 2 together, the 2 exponents. So this would be x to the 6. And then y to the 3rd and y to the 7, that would be y to the 10, and go like that. Now, let me do another example. Let's have 27 x to the 14th, y to the 8th, 3x to the 3rd, and y to the 5th. Again, split like terms, deal with them one at a time. And then if I divide 27 by 3, I get 9. For this one, for these two, I'm going to use what? The quotient rule. The quotient rule tells me what? If I have the same base, all I need to do is subtract the denominator from the numerator. So this would be 14 minus 3 is 11, and 8 minus 5 is 3. So you have 9x to the power of 11 y to the 3rd. Okay. 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 Now there are 2 more items, and you have seen this before to discuss before we end with this session. The 0 exponent and negative exponents. Negative exponents. Now, we know anything raised to the power of 0 is 1. 2 to the power of 0 is 1. Anything to the power of 0 is 1. And this makes sense because of the quotient rule. Suppose, let's say, 2 to the second over 2 to the second. Okay. If you do it without using the quotient rule, you would say what? 2 squared is what? 4. And then 2 squared is 4. 4 over 4 is 1. But go ahead and use the quotient rule. Because of the same base, we are going to subtract the denominator from the numerator. So that means what? I'm doing 2 to the power of 2 minus 2. And 2 minus 2 is 0, and 2 to the power of 0 is 1. This is where we got the rule that anything to the power of 0 is 1. Okay? Now, just a caution. Eight to the power of 0 is 1. Negative 8 to the power of 0 is also 1. Because what we are doing is what? We are raising not just 8 to the power of 0, but also negative 1 to the power of 0. Everything is 1. But if you have negative 8 to the power of 0, it is negative 1. So be careful the difference between these two. In this instance, the 0 belongs only to 8. So you go ahead and raise 8 to the power of 0 is 1, and then what? Bring the negative sign into it. Okay? Okay, and also, you might have, let's say, 8x to the power of 0. So, meaning what? This is 8, because x to the power of 0 is 1. 1 times 8 is 8. And don't confuse it with this one, because this time we are raising not just x to the power of 0, but also 8. That is 1. Okay, so note the distinction between the two. Okay, now one more item before we close today's session. And then you will get an assignment involving these concepts. Negative exponents. The negative exponents, like so, meaning what? If you have 2 to the negative 2, it's not telling you to do anything of a negative number, but it's a direction what you need to do to 2. If it is a negative sign, what it's telling you is find the reciprocal of 2 in order to make this one a positive exponent. So 2 to the negative 2 is what? What is the reciprocal of 2? It is 1 over 2. And then raised to the second power. Okay? We are going to change it into this. So this becomes what? 1 over 4. The converse is also true. If you have 1 over 2 to the negative 2, okay, 1 over 2 to the negative 2, what it's telling you is change this into a positive 2. In order to do that, you have to what? To find the inverse of 1 over 2, which is 2 over 1, or 2. Then this becomes 2 to the power of 2, which is 4. Okay. So, just to wrap up, for all real numbers, if you raise a to the negative n, it means 1 over a to the n. And for every 1 over a to the power of negative n, it means a to the power of n. Okay. These are the rules of the negative exponents. Meaning what? Whatever we do, when we write the answers, we always have to write in positive exponents. So let me give you some exercises on this, some examples. So, 5 to the negative 2. That is 1 over 5 to the second, which is 1 over 25. Negative 2 to the negative 5. This means what? Negative 1 over 2 to the power of 5, which is negative 1 over 32. Mind you, I didn't change the sign. The only thing is what? Just find its inverse. 1 over 6 to the negative 2 is the same as saying 6 to the second, which is also 36. Okay. And then you can end up, you can have also this kind of problem, 7x to the negative 5, y to the second. So all you need to worry about this expression is what? How are you going to change negative 5 to positive 5? All you need to do is what? Bring down x. This one stays on top. This one stays also on top. But x to the negative 5 comes down to become x to the fifth. And then we're done. So, before we end this session, we're going to do these exercises. Sorry, I keep on. Let's do these 3 problems. To the third. Okay. We are using all the rules that we have talked about. So let me combine the like terms. So this is negative 3 to the third, x to the fourth to the third, and y to the fifth to the third. Now, if you raise negative 3 to the third, you would end up with negative 27. X to the fourth to the third, use the power rule because you are raising the same variable to different powers. Just go ahead and multiply 4 times 3, which is 12. The same also holds true, 5 times 3, y to the 15th, and you're done. Then you have negative 7xy to the fourth minus 2x to the 5, y to the 6. This is an example of a product rule. Now go ahead and multiply negative 7 times negative 2, it is 14. Then x times x to the fifth, meaning x to the first times x to the fifth, gives you x to the sixth. Y to the fourth and y to the sixth gives you y to the 10th. And we're done. Now let's do negative 35x squared y to the fourth and 5x to the 6, y to the negative 8. Once again, divide negative 35 by 5, you would get negative 7. You are going to use the quotient rule, x to the second over x to the 6th, subtract 6 from 2, you get x to the negative 4. Y to the fourth over y to the negative 8, you are subtracting negative 8 from 4, it means what? 4 minus negative 8, you end up with y to the 12th, it becomes positive. Now all you need to do is what? Solve for x to the negative 4, meaning what? Change the exponent into positive, so negative 7 stays on top, y to the 12th, and then you have x to the 4th, and you're done. Now, the last one, I promise, would be 4x squared over y to the negative 3. This is involving negative exponents. So before, you can do two ways. You can distribute 4 to the negative 3x, or you can do, because it is a negative exponent, you are asked everything inside the parentheses, just turn them upside down. Okay. So meaning what? Find the inverse of 4x squared y, which is y over 4x squared, and this makes it positive 3. Now you can do what? So since everything is raised to the 3rd power, so this is y to the 3rd over 4 to the 3rd times x to the 2nd to the 3rd. Your y to the 3rd becomes still y to the 3rd. 4 to the 3rd, it gives you 64. And this one is a power of x to the 2nd raised to the 3rd, is meaning what? Multiply 2 times 3, which is x to the 6, and we're done. So we're done with the first session, and you will get an assignment based on that. And see you in the second session.